education coordinators, and I'm excited to welcome you to this evening's event. Now, we're going to have some time to talk and ask Kevin some questions at the end, but I just wanted to introduce him a little bit, even though many of you, I'm sure, have seen him on your TV screens for the last 18 years at least. So Kevin, he earned his degree in meteorology from Lyndon College in Vermont. And he's going to talk to us a little bit about what it's like to be a meteorologist, as well as some of the space weather that we experience that will help us understand a little bit about what's happening on our Earth. Now, Kevin, is there anything specific you'd like me to mention?
Not that I can think of.
Me and Kevin spent many hours before the eclipse here in this building since about 4:30 that morning, together doing some recording. So we've spent quite a little bit of time compared to that. So without further ado, I'm going to welcome Kevin Skarupa to the microphone. I hope you all enjoy the presentation.
Thank you. Meteorologists are not used to applause. Leave it at that. We're very used to the other way around. First of all, thank you very much for having me. I must confess, I would say 80 to 90% of my talks are to kindergartners and third graders. But these are always fun opportunities and ways to be able to kind of broaden out what we talk about. I'll make sure I leave plenty of time at the end for questions. When I am going to talk to a really smart school like Academy of Science and Design, I intentionally fill most of the time with my talks so that there's very little time for them to stump me at the end. I'm not going to do that tonight. There's little tricks of the trade like that. But thank you for having me. I have a wonderful job. I really do. I am blessed for a job that I kind of knew somewhere around 12 or 13 years old. It's what I wanted to do. I didn't think the TV part, there's so many different kinds of meteorologists, that the TV part would be the thing I do. I never raised my hand asking questions in school or anything like that. I was a pretty quiet kid most of the time. So I didn't think automatically that I was going to wind up on television someday, but it has kind of worked out as a way to be able to predict the weather on a daily basis. I always tell people that I'd be just as happy working out at an airport doing weather observations. I really love the weather part about what I do more than the TV part. The least favorite part of the job is obviously the alarm clock, which goes off at a nice crisp 1:30 in the morning. But other than that, you know, it's been something that I've been able to make a career out of, which I'm really lucky to be able to have that. I realize that the television landscape has changed dramatically over the years, and it isn't usually people sitting home, you know, at 6 o'clock every night watching a full half hour of news anymore. We're consumed in totally different ways, and we've slowly adjusted in time. More than half of my workflow now is social media and being posting on the internet, because that's where people have been getting their information lately. So I'll talk about kind of the subsection of weather, which is the space weather part. There's a lot that we can learn from what we're learning about what's going on in space and kind of relate that to our Earth system. I kind of basically theorize that meteorology is a 500-piece puzzle out on a table. We know a lot about each piece. We know a lot about the sun. We know a lot about ocean currents. We know a lot about atmosphere. But it's how all of those pieces connect, pull, change, and affect each other. Even though we've been using computers for 50 years to figure a lot of these things out, we're not totally there. And we're not going to be totally there in 20, 30 more years. It's just a very complex connection or system between all those 500 things. And so we're learning more all the time. There's a movie coming out in a couple of weeks called Twisters. And they're likely going to make these storm chasers look a little crazy because it's Hollywood. But at the same time, the truth of that is that there are people chasing tornadoes as scientists. And it's because we need to learn more about some of these huge storms here on Earth. Hurricane hunters that fly into those storms to get data. That's a real thing that gets ingested right into the computer maps that we see 6 hours later. So all of that is out there. The one crazy part is that we make over 4 billion data points, weather observations on a daily basis. There is going to come a point, they think it's about 12 years from now. I don't think we have a doomsday clock on it or anything, but there's going to come a point where they're not sure where they're going to be able to store all of that data anymore. They're going to run out of space. There's nothing technology-wise currently that will be able to take all of that information. And the historical data is very, very important. It's what a lot of the maps base their initial starting points on and where, let's say, a hurricane's going to go. They'll look at the 25 times it was in that spot, and they will kind of lean in that direction. So to not be able to store any more historical data, hopefully is something technology-wise that someone is inventing. If you're looking to make $1 billion in a very big hurry, come up with a solution to that. That is the next big thing as far as meteorology is concerned. Just a little bit about me, born and raised in Fairfield, Connecticut. My parents still live there to this day. Lyndon State College, unfortunately, was totally underwater as of yesterday. We saw the video, and they're in a river valley, right along the Connecticut River up through the Northeast Kingdom of Vermont. And they get a lot of flooding. They just do. There was when I went to college there. Please don't do the math on the age, by the way. But I have never seen the downtown area. And what's amazing about that is it was 3 to 4 inches of rain. Yes, in a very short amount of time, but it wasn't 10 inches of rain. It wasn't a foot of rain. It just doesn't apparently take a lot in a short amount of time. It was a flash flood. But those bouncing around, KIMT was in northern Iowa. I was Kevin Joseph in 1998, 1999. The Skarupa name was apparently too complicated for viewers. This was a different company at the time. PBF is West Palm Beach, Florida. KRN is in Nashville, Tennessee. So you can see how meteorologists kind of bounce around for a while, then they find that one place. My wife, born and raised in Merrimack, New Hampshire. Happy wife, happy life. Read a lot of books about weather, watched the Weather Channel as a kid, made a weather station in my backyard when I was 13. The anemometer, the suction cup whirligig thing that measures wind, was always the thing on a windy day. It would wind up in my neighbor's yard. By the time I got to Lyndon, I figured out a way to finally do that the right way. But I had started looking at colleges at 15. At 15 and a half, I walked into the meteorology lab at Lyndon State, and it basically ruined my junior and senior year of high school because I knew what I wanted to do, and I had already mentally gone there. And I realized it's a rare thing. Maybe teachers, maybe something like a pilot might know, but it's a very rare thing that you know that early in life, kind of at least the subject matter of what you want to do when you get older. I was a product of the blizzard of 78, but not how you think. I was in second grade at the time, and this blizzard in southern Connecticut gave us 2 feet of snow. It happened on a Monday, for those of you old enough to remember, and I was off from school Tuesday, Wednesday, Thursday, Friday. Snow cleanup is a lot different now, but it had me wondering how in the world can something like that happen, and how can it please happen again next week? So that's where the library visits started kicking in, and the wonder of how this all would come together would be. The light blue jacket was actually in fashion in 1995, is what I tell people anyway. But again, it's kind of just a bouncing around over the first several years of your career. You take that first job out of school, wherever it is. And yes, I asked my wife from Merrimack to marry me on live television. That video is out there on the internet somewhere. Before I left the station to go do this live shot, I had a segment called Kevin's Supper Stops. And this was the one that was closest to our house in Mason City. And the main anchor, Brian Mastery, who still is an anchor now in Omaha, Nebraska, told me just as I was leaving the building to go do this, he knew I was going to be proposing. He said, by the way, if she says no, stay on TV. It's great television. So Yes, she did say yes, obviously. Spoiler alert. And I think even to this day, she's not necessarily thrilled that I did that on live television. I think she thinks that I didn't really give her an opportunity to say no. The school visits are the fun part of the job. They are the way that I can actually see the people I talk to. It's me and a camera in a studio. There's nothing to be nervous about. Also true, the anchors are not paying attention to literally a word I'm saying. So yes, I am in the studio talking to myself basically. So when I go out and do the school visits later that morning, it's the perfect remedy for everything. And it's really great practice for being on television because you can see the reactions right in front of you. Allows us to do a lot of different things, including going into the Atlantic Ocean on Super Bowl weekend. They have a theme every year. Top left was Adam Sandler in Wedding Singer. Alvern High School raised the most money, and I gave them, because they raised the most money ahead of time, the option to decide what I was going to wear. So they put me in a cheerleader outfit. It's a lot of fun though, and they've raised millions of dollars over the years for it. So as I mentioned, the technology challenge for us, before we get to all the space stuff we're going to talk about, is that it's almost impossible to compare generations. The storm tracks that you're seeing on the left were in 1933. We didn't have satellites. It was more boat reports that were out there. So it's tough to compare a very busy 1933 season to a 2005 season when we did have the satellites and all this other stuff. It makes it really difficult to make grand declarations about trends and things. Something as simple as how many tornadoes we get on a given year, now that everybody has a cell phone and basically a working video camera, that if you're out on a small town out on an open field and you happen to see it, you can take a quick video of it and the Weather Service will then declare an official tornado. So the numbers, it's just really difficult to pin everything down into exact trends most of the times because of that. Hurricane Sandy was, as far as my career has been concerned, the one time that I realized we're on our own. The computer maps do a decent job. This is every different computer map 5 days before it made landfall in New Jersey. And as you can see, a lot of the tracks from all those hurricanes had it venturing out to sea. So out of, I believe there's 18 or 19 of them there. One of them got within, about 50 miles of where it ultimately wound up. So when you hear us say on television, we're 5 days away from a big winter storm, we don't have an accumulation map on the screen. We aren't necessarily just telling people, stay tuned for updates just because we want people watching us again the next day. Maybe the bean counters are thinking that. But we as meteorologists, there's only so much we can do so far away. This has gotten better over the years. Even in the years that I've been on TV, there were 2 different sets of computer maps when I started back wearing a light blue jacket. Now there are 9. You could say that might be too much information. I like to look at it as when you went to the grocery store 25 years ago and you needed to buy peanut butter. When you went in for that peanut butter, there were probably 3 different kinds. Now there's 25. It's the same kind of thing, which is a good and a bad thing. There's a lot of noise on the maps, and they're not always perfect. This was the 1950s up and down the East Coast for tropical systems. We have gone 85 plus years since a landfalling hurricane gave us a 100-mile-an-hour wind in the state of New Hampshire, the hurricane of 38. Knocked down 1 out of every 3 trees in New England. So that's the one thing, if you were to sit here and ask emergency management here in town, the one thing out of all the ice storms and the flooding events that we've had, the one biggie that's out there, because as you probably noticed, if you just look out at the trees and just how far they've grown in 85 years, we get power outages from 40-mile-an-hour winds, and it's not necessarily just because the winds are stronger or anything. It's just they have grown a lot. And that is, it's, I think in Cologne, going all the way back to 1600, a landfalling hurricane, the power of 1938 has happened 3 times. So it's about, 80 to 100 year kind of storm. It's a lot of things that have to happen. It's a 6-week window in which it can happen. So it's not going to randomly happen now in middle of July. It's late August to early October. It takes certain things. It has to be fast moving, but stay offshore so it continues to hold its strength, and it needs to be fast moving. So by the time it still gets here, it has winds that strong. So there's a lot of things that have to happen, which is why it only happens once every 80 to 100 years. I should say, just because it hasn't happened in 85 years doesn't make it more likely to happen next year. That's just not how it works. So I'm hoping I'm retired by the time that happens again. I hope the microphone caught that. All right. So the troposphere, almost all weather, almost all, happens in that very small slice of the Earth's atmosphere. So yes, as you can notice, satellites are in a certain spot. Meteors entering our Earth's atmosphere are in a certain spot. Some of the higher planes can be in certain spots. Some of our really tall thunderstorms can go 10 miles into the air. And then that moisture is kind of left up there. The Google term that I will give you for tonight is noctilucent clouds, is what they're called, noctilucent. And that is in Canada, early summerish, vapor that is left way up in the atmosphere creates a certain type of cloud that when the sun is setting, it makes the clouds almost like glow. They're very difficult to find. As a matter of fact, I Google searched and only found like 2 pictures, and they weren't as spectacular as people describe. So almost all of meteorology happens in that lower atmosphere. But as you can see, there are so many other layers to our atmosphere. And with satellites up there looking down at Earth at all times now, hundreds of them, it allows us to really learn a lot about what's actually going on down here at Earth. There's been some amazing discoveries in thunderstorms now that satellites are looking down at them at all times, including a third different kind of lightning in the last 15 years that we were not aware of. There was cloud to ground, cloud to cloud. There's a third type called a sprite, just like the soda, that goes up towards space. And we could see it from the ground. But now they're realizing that every time there's a really nasty thunderstorm with a lot of lightning coming out in all directions, sometimes it just spits the lightning out going up. It doesn't hit a satellite or the moon or anything. It eventually travels across and then comes to the ground, sometimes 10 or 15 miles away from where the lightning originated. They call it blue sky lightning. People have been in recorded history hit by lightning 10 miles away while the sun's out. You think you've had a bad day. But now we have an actual reason as to why it's happening. We, on Storm Tracker, can see these hundreds of lightning strikes along a line of storms, but we could never understand why there would be these 1 or 2 strikes much farther away. And now we kind of see why that is, but that's all because we have satellites up there looking down at Earth to figure it out. So, best way that I can describe how science works is by the ill-fated planet Pluto. The adults in the room will remember that we were taught there were 9 planets. 4 made of rock, 4 made of gas, and then this Pluto thing out farther in our solar system. As we got to learn more about the solar system, we realized there were other things out there like Pluto. So New Horizons decides to send a spacecraft out in that direction. Everything we had up until New Horizons was this little fuzzy dot. It was small compared to, let's say, Neptune or Jupiter. So I remember this day well. It was a Friday morning. Let's see, it says July 19th, 2014. This was the closest image of New Horizons looking at Pluto and its main moon named, I've heard Charon, Charon. I've heard different pronunciations for that. So this was all well and good. I remember this day of sitting there right before a noon show. And it was the moment that they took 4 or 5 of those photos and they put them together. At that moment, my mind was totally blown. My wife heard way too much about this when I got home from work. But obviously, the fact that Pluto doesn't really control its own neighborhood and Charon's kind of pulling and tugging at it because it's half its size, making a little bit of a do-si-do kind of thing going on there. It kind of verified the fact that, Pluto doesn't control its own neighborhood. It's not big enough. It's not strong enough. So to actually give it a planet name like the others that do that, that's really the way science is. New discoveries make us kind of bend our minds a little bit. And space allows a tremendous amount of that. The reason that there's a bunch of mysteries out there in space is simply because of math. There's a reason we know the minute an eclipse is going to happen, and it's because of math. The reason we don't understand certain things out there in the solar system is also because of math, not because of what we know in math, but what we don't know. Black holes, for instance, there's no math equation that can explain exactly how that works. So we don't understand it. I don't think third graders want to be told that math is really, really, really important, but in the end, it really is. And so that's why our mysteries out there in space, our understanding of way math is only to a certain point. The aurora borealis is probably the one type of space weather that I think a lot of people relate to. The more we learn about other solar systems that are out there, what is the name of the one that's like looking deep into space? What's the name of that? No, which one? James Webb. Thank you. I'm glad you're here. The more we learn through James Webb, the more we learn about these other solar systems out there, we realize that we're not necessarily like a lot of the others in a lot of different ways. But we know that our sun is, it's not the strongest sun out of all the different stars that's out there. But at times, it has storms on the surface, just like Earth does, called sunspots. And some of those give off energy, and that comes toward Earth. Now, we are really lucky here on Earth. By no invention of humans, we have a nice, wonderful magnetic field that protects most of what comes out of there. If not, we'd be Mercury or even Mars to a certain extent. There would be no weather available to us. All the moisture would be just whisked away, and we would be just another dimensionless planet. But we have instruments out there looking at the sun really carefully. We don't know exactly everything about it. We know enough to get by, but these flares that come out through from the sun to our Earth create a certain reaction. Chances are, if in the last 10 or 15 years you've been told by yours truly or somebody else, when yours truly says it, I love talking in third person. I have a certain skepticism as to if it's actually going to happen that night, because in my entire life, I've only seen the aurora once, and I have gone to work early in the morning for the last 22 years. So I have a healthy skepticism. But then I go to work and I look at the Mount Washington photo that they have just sent out, and I say, yep, there it goes again. But that reaction that happens, provides us an amazing view here on Earth when it happens. So this is what it looks like from space. And it's a matter of exactly how strong that reaction is when it gets here to if it will come far enough south away from the Arctic Circle for us to get the amazing view that it is. You can go to certain places, Iceland, central Canada, where the rivers all run north, and have an infinitely better chance of seeing it than around here. But we do have situations where it does happen here. There are certain spots, if you were to just Google image New Hampshire, Northern Lights, Aurora Borealis, you're probably going to notice that there are certain photos in certain places, like Ossipee. There's certain locations that tend to see it than a lot of other places. And again, part of it is away from city lights, but there are certain locations that are a better chance to catch it than others if you're dedicated. Again, not all of them are totally telegraphed, like an eclipse where it tells you from midnight to 3 a.m. on this particular evening, there's going to be a really good chance. And sometimes the weather obviously is going to play havoc with that too, because some nights it will just be totally cloudy and not allow us to be able to see it. But that's probably the most famous one. And those sunspots and solar flares that come out through the solar system, they have a certain trend to them, which again, through science over the years, we have seen a lot of these peaks and valleys. So it's about every 11 years that it peaks, and a much larger 22-year cycle. We're nearing a certain point on that ramp up now. When about-ish is that peak?
This year, NASA considers to be the solar big year, the heliophysics big years, what they call it. So between like October and middle of next year is when they're anticipating the maximum. So
a decent chance, that there's going to be, better chances to catch it as we go forward. Again, the clearer skies is always but you can go back through history. So yeah, this is what happens at about 4 a.m. every morning. And you could probably hear me clear across the newsroom scream when I see this picture, when I have been driving to work looking for it. It's so annoying that they get the best view up there. But yeah, obviously they can see much farther away and have that best chance to catch it. And of course, they're truly away from city lights for the most part, although you can see some city lights down there in the distance. So it doesn't really affect them too much. So spaceweather.com is my favorite website. They provide you all of these really cool meteor shower information to the solar flares and when they happen. And they provide, this isn't necessarily live, but it's updated about every 3 to 4 hours with where the sunspots are as they rotate and where the flares are and the geomagnetic storms when they happen. It's a fantastic website, updated every 6 to 10 hours with what's going on. And I think they do a really good job of not over sciencing it and making the words really complicated that they're talking about. But they do a really good job. There's other websites out there as well, but this is the one that I tend to click on pretty much every morning. There's a certain section of websites that I look at every morning as I come into work. And this is part of that because we realize as meteorologists, yes, you're there to get the forecast for the day. But if there's a volcanic eruption or an earthquake nearby or something, a meteor shower or this, you're probably going to want to know that as well. It's kind of a station scientist thing in a lot of ways for us. So space weather, this is one of their photos, and this is provided on their site, updated about every 6 to 8 hours. So they give you not only where the sunspots are, but they give you what is known as the aurora circle of how far it's extending out from the Arctic Circle itself. And there were times with that event a couple of months ago where it was all the way down right along the border with the United States, which provides us with the best chance, providing that the weather is good, for us to be able to see something like that. Along with the aurora borealis, meteor showers, I think people see those in the sky and they assume that they're a certain, magnitude. Those are grains of sand, most of them. We have situations where they're bigger than that. But a lot of what you will catch with the Leonid meteor showers, or a lot of the others that happen as we go through a comet's tail debris over a course of a given year, usually in a certain month every year, provide you with, a way to be able to see, 10 to 15 per hour. There are times where it goes through a more significant portion of that remnant of the tail. And I haven't seen them personally. I don't know if you have either. You're always looking for them also. I ask her not just because I'm not asking anybody, but I figure if anybody's going to be looking for them. But there are times where you have that chance of seeing 100 in an hour, 150 in an hour, where it looks like on a really dark night, you're probably almost like in the movies where you're shooting through space and they're coming at you in a lot of different ways. But those, again, those peaks are not necessarily something that we see all that often as well. In general, a lot of the space events aren't, givens, unlike the solar eclipse, where we were pretty much down to the minute. We got incredibly lucky during the solar eclipse that we had totally clear skies that day, and it wound up being a beautiful day. And the next time that happens, let's see, it is May 1st, 2079. I don't know how that's locked in there. But that just gives you an idea as to how rare something like that right over us is. And I believe that one is as the sun is rising in the morning. It's an early morning one as opposed to one that was early to mid-afternoon. So it'll be a little bit of a different one. But May 1st provides a slightly better chance than April, which leading up to the eclipse, that's all I said for several years was, it's April, it's New England. What do we say about April? April showers. I am glad I was never been more glad to be wrong. But we could see that coming 5-6 days out. It looked like clear skies and you were just hoping it wasn't going to change, because the last thing we wanted to do is, build that up and then a bank of clouds moved in that afternoon, or anything that would really change things up a lot. Any questions about anything? As we kind of leave the space portion of this, I'm happy to answer any questions you have about television, science in general. I'm a little leery of doing that with a microphone, but gossiping about the anchors and all that sort of stuff. There's plenty to talk about with that lot out in the newsroom. Yes.
Like where did feet come from in the first place? Like how did our feet evolve?
Whoa. Wow. That is a good one. All right. So you have to imagine that we as, and you can kind of take this from space. Space is kind of the Goldilocks thing where we are from the sun, not too close, but not too far away. As we have looked at other solar systems, you can correct me if I'm wrong on this, but I think I've got this. As we look at other solar systems out there, we realize that we are a very stable solar system compared to others. A lot of the others have what they call a hot Jupiter, which is much closer to the sun orbit. Like where Earth is where their Jupiter is. And our Jupiter being farther out kind of almost acts like a balancing act and kind of absorbs a lot of things that come into the solar system and kind of makes our solar system pretty stable. So what has happened over millions of years is we have evolved. Now, obviously, we find fossils of dinosaurs and then a magical asteroid, comet. I've seen that change over the last 10, 15 years of exactly what they think it was. Took the dinosaurs out, then we started evolving again. And that's kind of where it all happened for us as eventually human beings. The feet, I mean, what would we do without feet? So, the ones that developed feet, survived best. And then as generations kept going, the ones with the feet were the ones that stayed. Yes.
I have 3 questions.
Okay.
The first one is the past few summers,
Mhm.
I've noticed that it's been ridiculously hot and humid in New England to the point that it's actually cooler in Florida.
Mhm.
And I want to know why, and is that going to last?
Is this a thing that continues? Yes. So all I heard last year was how cold and rainy last summer was. And all I kept telling people is I'm like, you just be careful what you wish for, because then this stretch happens and people are, all they're saying on my Facebook page is like, wow, when is the humidity going to leave? I'm like, September. I don't have the greatest bedside manner with people, and it is my weakness. I fully admit it over 25 years of doing this. I always go for the funny in those situations as opposed to the honest answer. So here's the trick. We have doubled the population of Earth since 1960. What we have essentially done since 1960 is we have taken water out of the water cycle and built more buildings, more roads, more everything. I'm not blaming the amount of humans per se, but much like I told you earlier, and just comparing generations of things, it's difficult. The humidity is something that has been a thing that over the last 15 to 20 years, if you go back through, there aren't tremendously detailed records on, let's say, dew points down to the hour that go back 20 or 30 years from a certain reporting station. But it has been over the last 4 to 10 years in the general trend, more humid. I don't know if they necessarily have a particular reason beside the fact that even if it's 1/10 of a degree, the warmer you are, the more moisture air can hold. So the warmer we get, the more humid we're going to get with it. That's part of it. It's not probably the answer anyone wants to hear. But again, it doesn't have to be 2-3 degrees over 100 years. It can be 2/10 of a degree, and that does hold more moisture. And it allows, when you're holding more moisture, it kind of soups up the water cycle that little bit more. Again, it's not a lot, but it allows for more heavier rain thunderstorms. I'm not necessarily saying what happened 2 nights ago is the exact thing. It was 2 to 4 inches of rain in 18 hours.
Oh, is that?
Yeah. Yeah, we didn't see anything down here, but it wound up being more of a flash flood situation, even though it was kind of the outskirts of the remnants of Beryl. So when you get those a month's worth of rain in 18 hours, the rain just doesn't have the normal places to go. It's not going to just fall slowly and neatly into the storm drain. It's going to find other places to go. And that's why that happens. The danger was you have all these campers and hikers up there. It's happening at night. You're just hoping that everybody gets word when this is happening. And I think there was at least enough of a signal leading into that day that we were kind of pointing toward North Country and saying, this is probably where, if it's going to unfold, this is the area. In the end, we can look at a map and it says 2 to 4 inches of rain for that area, but we don't exactly know how it's going to do what it does once it falls. We don't know if it's just going to be a buildup on the rivers or if there's going to be major damage and roads washed out. There's no map that tells us that. But it is, if we do have that little bit of extra humidity in the air and we do have that little bit warmer temperature, it just makes the actual water cycle itself that little bit more efficient in the months of the year in which that happens. Especially this time of year, where when you have a dew point over 70, that's tropical. Yeah. You had a couple of other questions.
The second question is, what is the weirdest thing you have ever seen in the sky or on the Doppler or radar? Something that you were like, what is this? In your whole career.
Yeah, see, the radars have gotten so good over the years. I mean, we're at a point now where we have 50 of them. None of them are located in New Hampshire, and that's fine because the beam slowly comes into the state. The radar beams where you have 4 of them coming into the state. Now these radars are developing 2 beams called dupolar radar, where now we're going to have 8 beams coming in at different levels of the atmosphere. So when we see rotation in the clouds, we know that that's a half mile up. It doesn't necessarily mean there's one on the ground, which is why when there is a tornado warning, it's radar indicated because there's a spin in the mid levels. we don't know if it's actually going to hit the ground. It did in Dublin, but it didn't in Littleton. But it was the same almost exact radar signature, which is the strange part. It's, the strangest one of all for me is the 2008 tornado that was on the ground for 50 miles in the state of New Hampshire. That day, we had a flood watch up. There was no chance of storms as far as we knew. I think there was an unofficial sighting of a funnel cloud in Atkinson as it was coming into the state. And that is what prompted the tornado warning originally. There was no, you'll go back and look at the radar signatures. There's nothing there, even from 2008, that showed us that there was tremendous rotation with that it could be on the ground for 50 miles, making it the longest track in New England history. So that, I think, to me is the most surprising thing, as opposed to something that's just up in the sky that I can't totally explain, is the radar not really showing us, a 50-mile path tornado like a textbook should. It was a crazy day. I mean, we were on the air for 6 hours that day. It was an EF2 at one point near Ossipee, 13 different towns. It was a half-mile wide at one point. But again, the radars it was rain wrapped, but radar can go through rain. I can see what's going on inside. So there was no one actually saw it visible because it was in the middle of the heavy rain that created that storm. But I think that's kind of the quirkiest thing, is you can go back and Google radar images from that day, July 24th, 2008. And there's no really good radar signature showing that this thing was. So while we were tracking it on live TV, we could see what they were warning us for, but we weren't looking at the normal products that we would be looking at like they do now, wind inbound and outbound. They talk about this reflectivities and all these other things now. There was no true way to track that particular storm. And to this day, it's kind of puzzling in a lot of ways.
Last question is, where did you get your tie?
On the back, it says 2017 Pine Street Head Start. So from one of my school visits. Yeah, the school visits again are truly the best.
How come when you look at it with there, like without surface risks, how does it blank even if it's getting to the Dublin?
All right, repeat that. It's late in my day. The storm clouds blind you? Oh, okay. Well, what was cool about Eclipse Day was the fact that even if you didn't have the glasses, and they could tell you stories about trying to keep the glasses in stock here. There were so many other really cool ways to observe that eclipse by, a little pinhole. There was just so many different ways. But obviously looking at it was the key. And I was semi-surprised that at 95% eclipsed, still how decently light it was outside. It's amazing to think that 5% of the sun could still give off quite a bit of light like it did. That was probably the one thing I learned from that day more than anything else, is like that 150-mile ride north probably would have been worth it. Yeah, I'm not sure I'm going to be around for 2079 when that happens again. My son might be, but I won't be. So the solar glasses, are a very special kind that allow you to kind of filter out a lot of what's going on. So you'll notice if you just Like if I were to just sit here with this ring and put them on, it's going to be very, very faint. The sun is just so incredibly bright that, you know, you really need to make your eyes very dark to be able to see the detail of what was going on. And it's incredible. It's in a kind of event that you realize 6, 10-year-olds, 15-year-olds, they'll remember that kind of day for their entire lives. It's a day that they will remember. For some kids, it's probably one of their first memories that they'll have is when I was, 7 years old, I remember that eclipse. And that's a really cool thing. It was a really neat day in that way. And it's almost, there are very few of those days that wind up being like science days, but that just happened to be one of them. Mm-hmm. Okay. Well, I mean, I'm kind of partial to Earth. And I kind of feel like I have to say that because I forecast it every day. And I feel it would be very bad karma if but it's tough to not be in awe of Jupiter and just how enormous it is. It has lightning and all these other things. And while we can theorize what goes on, toward the middle of it as something gets dropped in there, I mean, we just truly may never totally know. And that in itself is a pretty cool thing. Mm-hmm. That happens to me all the time on live television. A really, really, really long time. Yeah. Yes, I will be in a Subway ordering a sandwich, and the person there will say, yeah, you came and spoke to my class when I was in 3rd grade. And so yes, I would agree with you on the Earth thing. Earth treats us pretty well. It allows us to be, as far as we know right now, the only living beings in our solar system. That may change in our lifetimes, but for now, it allows us to be able to do that, right? Right. That we know of. Right. What's that? Oh, thunder. Very cool. At the end, can I get a picture with thunder? Yes. Ooh. That is a really good one. Okay. I think the namespace, if I could just scatter shoot this, is probably because when we looked up there, we didn't know much about it. And it was just this big space that was up there that we didn't know much about. Now, obviously, through technology over the last 100 years, especially, we have learned a lot more about what's going on there. Mysteries are solved all the time, but it is a space that, as far as we know, is continually expanding all the time. Okay. Oh, that's a good question. I truly enjoy my job. That's the first thing, which is the best suggestion that I try to give to like 3rd or 4th graders is find what you'd like to do, because you're going to have to do it 40 to 45 hours a week or more. So you might as well enjoy what you're doing. I enjoy the challenge of predicting what the weather is going to do. And there are certain days where it is a much bigger challenge than other days. Just like school. And I will tell you that meteorology does seem like I'm in school all the time, because we do learn more all the time. We really do. it's a science that we don't have everything totally locked down. And that's, I think, one of the best parts about it is that we don't have all the answers. And it makes it fun to come to work every day, knowing that on that given day, something that could happen that I've truly never seen before or wasn't even expecting. Yes.
Period.
Mhm.
To the best of my knowledge, the U.S. Geological Survey is like in charge of the land and, you know, the drainage basins, so to speak, for rivers and things like that. And so you're on the side of predicting rains, heavy rains, et cetera, where the path is gonna go. And they're in charge of the land. I just wondered if you guys talk to each other. Are they just watching you on TV and saying, hey, we gotta be aware of this? Or any kind of.
I mean, not on a routine basis, but it is fascinating. So the one event that I probably gotten to know them really well was when the Suncook River changed course. This was during the Mother's Day floods. Avulsion is maybe the one word you'll learn today compared to anything that I've talked about. But when it changed course, that is a living, eating, breathing science experiment. And you know, by looking at maps that there's these curve-shaped lakes near rivers, that's generally where the river was until basically the Suncook River rose so high that it found an easier, lower place to go for about a mile. And so there is now a place that's just basically a sandy riverbed left over. And there is a mile of a neighborhood that has riverfront property that never thought they would. And over the course of the last, 15 years, his name is Steve Landry at DES. His job has been to try to contain that river. He still calls it unstable, meaning if another huge flood comes along, like let's say instead of the North Country, what happened a couple of nights ago happened over the Suncook River. He believes there are some spots where that river could still change course a little bit. He doesn't believe it found its final place. He thinks that in the next couple of 100 years, it'll move again. But he said it's his job for the rest of his career to try to make sure that doesn't happen on his watch. So they've been kind of reinforcing the basin, putting culverts in certain spots. It's a fascinating job. Something that I totally, if I had more time in a normal workday, would probably totally enjoy learning infinitely more about. But I think on the day-to-day forecasting angle of things, there's very little collaboration going on. The only time I think there is when they open the emergency operations center here in town. That is when they bring in experts from all the different fields. They have a meteorologist, they have a geologist, they have people who are on call or in the building while these events are happening so that they can make sure that they have the best information that they need in that situation. They might watch me occasionally. Steve has told me so. But again, like a flash flood situation, we were really lucky 24 hours out to be able to see all of the maps keying in on the North Country 2 to 4 inches of rain. We just didn't know what 2 to 4 inches of rain was going to do. If it was going to be roads washing out, or if it was just going to be rivers rising. There's really no map that's going to tell you that. But there are other times where thunderstorms pop up and then, let's say in a very slow moving wind situation, they're just not moving. And you get 7 inches of rain in 2 hours over a particular town, but the next town or 2 towns over, the sun's out. Impossible to know which towns those are going to be. There's a reason we use the phrase scattered thunderstorms, is because that's usually the way it happens. This was, the remnants of Beryl lifting northward and an interaction with the front coming in. So the maps were pretty good at being able to give us the one region of the 9 regions of the state of New Hampshire that was going to be really in the crosshairs that night. And I don't know if 25 years ago, we would have had a really good idea as to that was going to be the case. But I don't think people look at it that way. Also, the maps, I'm not saying they're perfect by any stretch of the imagination. I see one day before a snowstorm where one's telling us 1 to 2 and change to rain, and others telling us 6 to 12. But in situations like 2 nights ago, it was a really good benefit. And it was something that is a really feather in the cap to the maps, as opposed to anything we did. It was just the maps guided us right to that solution. And it played out kind of that way. All right, how about I wrap up with my most embarrassing moment on television? Okay. First job, light blue jacket, was not wearing it that day. Northern Iowa, we had a huge blizzard. This was my second year there. I was on during the morning show, and I got to work Wednesday morning. It was now Friday morning. Couldn't leave. It was just 2 feet of snow, wind blowing sideways, low visibility. So I'm up at the weather wall, and the picture you saw there in the light blue jacket is Amy. Her and I are doing the show that morning, and I'm at the wall. I hear the wind. Ceiling is about this high. I can hear the wind outside. And all of a sudden, a huge gust comes through. Lights go out in the studio. And I kind of feel my way back to the anchor desk, and I sit down next to my anchor, Amy. I feel like compelled that I'm talking about her. I need to go back to her picture. There we go. So I feel my way back to the anchor desk, and I sit down next to Amy, and we talk for a few moments. And there's a generator outside that we hear kick in. And then all of a sudden, the lights come back on. We start the show back up again. During our 2-hour morning show, this happens 3 times. Goes out for a few minutes, comes back on. We start the show back up. After the show's over, we go up to the newsroom for a few minutes before having to go back down and be back on TV again. And we notice that the answering machine, for young kids, answering machines were left messages kind of like voicemails. Feel like I need to say that. Was blinking, and there were 20 messages. So we listen to the first one, and it's Amy, it's great to hear you had a nice weekend last weekend. Didn't make any sense. Kevin, next one was, Kevin, why did you really not tell us what you thought was going to happen with the storm? Now, we had an audience that we took phone calls live on TV. This was 20 years ago. And again, think light blue jacket. We had a lot of fun. So we thought the viewers were just having fun with us. It was a big snowstorm. So we go back downstairs. We do another 20 minutes on TV. We come back upstairs. When we come back upstairs, our boss is in his office, laughing hysterically. We don't even know how he got to work that day, but he got there. He says, Amy, Kevin, come in, sit down. I have to explain something to you. We live in Iowa. Tornado could hit the station. Tornado hits the station. We have to have a way to be able to get the information out to the viewers, even if the emergency is us. So we have the generator outside, and that kicks back in a few minutes later. But we have a secondary generator in the control room that leaves incredibly important things on. I didn't realize it at the time, but my weather computer was one of the things I didn't have to go upstairs and reboot every time the power went out. I was just so tired, I wasn't even realizing it. The other thing that is left turned on in that situation are our microphones. So there's Amy and I talking in the dark about her weekend, about how I thought I should have probably forecasted another foot of snow than I did. And thankfully, Amy and I didn't say anything too colorful, because in New York, Chicago, Los Angeles, we could be fired for something like that, even though we didn't know what was really going on. Well, our boss thought it was so funny. He decided to sell videotapes of those shows to the viewers for $10 a piece. For the kids in the audience, videotapes are basically. So they sold thousands of these copies of the Blizzard of '96. Because we were the only station in North Iowa and everyone was home and watching us. Do you think Amy and I saw any of the money that they made from her? No, of course not. So you know a lot more about television. Thank you very much for having me here tonight. I really do.
So thank you all so much for joining us tonight. We have about 15 minutes before the planetarium show, so there's some time to explore a little bit before we head in. You are more than welcome to head down that way. There's bubblers, there's bathrooms, all of that as well if you need that. I want to thank Kevin again so much for joining us tonight. It's always wonderful having you here.
You guys want to be on TV tomorrow morning?
Yeah.
All right. Let me just get a quick video. Can we kill that light?
Got you.
All right, here we go. All right. So all I need you guys to do is just wave to the camera. Wow. Oh. All right. So tomorrow morning, it's the show end. I'm on tomorrow morning. It's a schedule thing. Show goes from 6 to 9, so let's say 8:45 tomorrow morning. And that long weather segment, 7-day forecast. At the end of that, the video that we shot now will be on TV. I'll make sure, I'll send a link along to you.
Okay, great.
If you want to post that anyway, okay? If you happen to miss it, I don't expect everyone to be up at 8:45 tomorrow morning. I will be hardly awake at 8:45.
That's your bedtime.
Yes, yeah, kind of a little bit, yes, but thank you again. I really appreciate it.
So just before